Alright, here's what I'm thinking. I want to build a powerful computer to better support the future of this channel. Something that makes it much easier to edit and render my videos in 4K. But I don't want to use a standard case. Instead, I'm going to build my own wall-mounted design that integrates water cooling in a way I've never seen before. I had a plan for this project before we even started building the workshop, so I've already placed all of the wires I need inside of the wall. This is going to allow us to have a really clean final setup. My finished design, including all of my models and drawings, is going to be free and available to anyone who wants to try and build something similar. I'll also share the costs related to this build. We'll break it down in detail as we go. I mentioned water cooling, and it's going to be a big part of this new design. My wife and I already built one computer that uses it, and I like it for a few reasons. The first, and I'm just going to be honest, is that it looks really cool. But on top of that, it's going to help us maximize performance while creating a system that is much quieter than a purely air-cooled one. We bent all of this tubing by hand on the last computer, and it was easily the hardest part of the project. So what if I could come up with a design that had no custom bending at all? Distribution plates, or distro plates, have been around for a long time in the water-cooled PC world, and the basic idea is to machine the fluid paths into a piece of acrylic, which is then sealed with O-rings and a faceplate. You see them on a lot of high-end builds, and they can be a great way to simplify the tube routing. So here's my idea. What if the entire front panel of my case was one huge distro plate? It would contain all of the complex routing of my loop, and then I can just make small straight sections of tubing to go in and out between the plate and my computer components. Once I had the idea, I spent the next 3 months iterating the layout before I ended up with my finished case design. As my design evolved, the cooling loop began to resemble a crashing wave. That happens to match the one piece of art I've hung in my shop so far, so I'm going to lean into it. Let me show you some of the main features before we jump into the actual build. We'll have time to cover much more detail as we go. The main structure for this case is going to be made from extruded aluminum and laser cut acrylic. It's fully enclosed to provide protection from dust and will house 6 case fans, 3 intakes at the bottom and 3 for exhaust at the top. I have 3 large radiators, which will provide plenty of cooling capacity for this computer. The radiator fans will be reverse blade, so they'll pull air from the back and out the front. This ensures the warm air comes forward instead of getting blown back onto my wall. I'm going to run LED lighting before mounting the finished distro plate to the front. That way I can edge light the assembly and show off all of the water cooling channels. I'm going to be using 2 DDC pumps in series, which gives me plenty of head pressure for such a long loop, as well as some redundancy. I'll also have a couple probes to measure the temperature delta between the warmest and the coolest parts of my loop. Then I can use that data to regulate my fan speeds. Lastly, I'll have a drain at the lowest point of my loop and a fill port up here at the highest. I have models for my purchase components, but I want to confirm measurements with the actual parts before I start asking shops to quote my acrylic panels. That means it's time to start buying stuff. Every part used in this build will be linked in the description below. In order to cool the CPU, I need to use a water block. This is the part that the water is actually going to flow through, and it mounts on top of the CPU. This one came with the thermal paste already applied on the backside of it, and this is going to assist with the heat transfer between the 2 parts. For memory, I'm using 64 gigs of RAM. This is only going to use 2 of our 4 slots, so I'll be able to double this in the future if I need to. For the GPU, I'm using a NVIDIA 5080, which should be a massive improvement over my current card. Back when I built my first computer, the 2080 Ti was the cutting edge, but now 6 years later, the 5080 has more than double the processing cores. Most of this unit is actually an air cooling system, which we're going to be replacing with another water block. It's crazy just how small the actual card is once you've removed all the air cooling equipment. I'll clean off the old thermal paste with some isopropyl alcohol and start preparing the new cooling block. These pads are going to work just like the paste, helping heat transfer between the two surfaces. And right before I attach the new block, I'll spread some fresh paste on top of the main chip. The back of the card will get some thermal pads as well to help spread heat to this large backplate. And lastly, we have the power supply, which is going to be an 8050 watt unit from Corsair. So far, we're at a running total of $2,560, and for reference, I purchased these components in July of 2025. One of the fastest ways I can confirm my models are going to match the actual parts is with a 3D scanner. I can capture a point cloud for each part and then bring that in a blender to see if everything lines up nicely. With everything confirmed, it's time to order our aluminum framing. I ordered all of this cut to size with custom holes pre-drilled where I'd need them. The total for all of this came out to $364 with shipping. Like I mentioned earlier, all of the CAD for this project is totally free to access on Onshape. I'll have a link in the description if you'd like to check it out. All I ask is that you please consider subscribing if you find any of this helpful. It really helps support the channel and makes it much more likely that I'll be able to do more projects like this in the future. Of course, I missed one hole when I was ordering my framing members, so I'm going to have to 3D print a few drill guides to help me get it in the exact spot. This is a counterbore hole for a bolt head, so I need 2 guides to help get it done. And I also missed a tapped hole in the end of one of the members, so I'll just have to add that in now. Now that my electronics have started to arrive, I'm going to lay everything out and start thinking about cable management. I'm using an Aqua Computer Quadro, which is going to be monitoring those water temperature probes I mentioned earlier. In order to power the fans, I have a couple hubs to simplify wiring. This first one is for the radiator fans, and this smaller one is for the case fans. The first laser cut panel I'm going to need is the one that the motherboard will mount onto, so I'm going to send this over to the P2S to get it started. I've also added an ERV since my last video, which is this small unit that exchanges fresh air with the outside. At some point, I'll make an update video to cover all the changes I've made to the shop so far. My order for 10 sheets of 3mm acrylic, which is going to clad this case, was another $136. To mount the motherboard, I'm installing some heat set inserts into the acrylic. Next, I'll add standoffs to make sure there's clearance between the back of the motherboard and this panel. And with the motherboard secured to the standoffs, we're ready to mount it into the frame. I'm just going to make a simple French cleat out of an oak board I had left over from a house project. One perk of building my own shop means I know exactly where my studs are, and I made a cleat long enough that I'm going to be able to mount 3 of them. These screws were also something else I had left over from some floating shelves I built for the kitchen. I had a small split on one end while I was drilling my pilot holes, but it's not going to compromise the board. The screw heads are huge, and this cleat will be more than strong enough. Now to start making my custom brackets. I'm really excited to put the new Bambu Lab H2S to work on these. Given the warm environment inside of a computer case, I wanted to try making my parts using some engineered filament, specifically ASA. I've heard a lot of horror stories about printing these more difficult materials, but everything came out perfect on my first try. The first bracket is going to be the mount for the power supply. And before I can mount the others, I'm going to need some more of the acrylic panels in place. Sometimes it's hard to plan the perfect order of assembly, and the power supply had to come back off in order to get this new part in place. This is going to be a cable brace for the GPU, just something to make the wire routing a little more satisfying. I've got to add a few more heat set inserts. This first part is going to help support our GPU, and this next one will be the mounting assembly for our USB ports in the bottom of the case. Another batch of ASA parts and we can keep moving right along. To the right of the motherboard, I have a cable chase that's going to allow me to hide wiring. These printed parts are just standoffs to help create that space. Next, I have my extension cable for powering the motherboard. And the CPU power cables up top. This cord is going to power the LEDs inside of our CPU water block. I'm working to get all of the motherboard wiring finished before we install the GPU in front of it. I have the connectors for the case power buttons, as well as some LED and USB header connections. The GPU has 2 brackets to hold it securely. I've never been a fan of the way most cases just support it from the one end. First, I made a test piece out of PLA to see how this bracket design was going to fit. 3D scanners are super helpful. And then I went ahead and made the full version out of ASA. It took some searching, but I was able to find a GPU riser cable that was the perfect length for my setup. And with the GPU in its final spot, I can super glue some small clips to secure the power cable. Now let's move on to the radiator assembly. Before starting any of this, I made sure to flush the radiators with some distilled water. This is always an important step to make sure you've cleared out any gunk left over from the manufacturing process. I'm adding magnets to eventually hold the dust filters in place on the back of this assembly. They just press into place, and one of my clamps helped make this a lot easier. I don't want any of these wires visible from the front of the computer, so I'm capturing them within these brackets and passing them out towards the back. And here's a quick test fit of one of those dust filters. Before I can mount the radiator assembly, I have another side panel to install first. In order to keep the wires out of the way of the dust filters, I made these cantilever tracks that I can use for cable management. I also made lots of cable ties for better organization as we go forward. Next up, we have the mount for the screen we're integrating into this case. This bracket will also support our Aqua computer boards on the back of it, so I'll need a few heatset inserts as well. The second board is going to help control our LED lighting. I'm going to need to install fittings and cut the small tube sections that will connect each component out to the distro plate. With all the fittings in place, I can take measurements to figure out my tubing lengths. I had this cutter from back when I made the previous computer, but it's not so easy to work with. It just kept cracking my tubing no matter how slow I went. So I'm going to give this a shot on the laser cutter. I can't cut all the way through to the bottom, so I'm going to spin the tubing while being very careful not to move it, and then I can try cutting through the other side. Oof, I guess it matters which end I start cutting from first. Let's try that again. These came out really nice. I did a little bit of sanding to polish the ends, but they didn't need a whole lot. And now we're finally ready to install the new distro. It's been 5 weeks since I ordered these parts, and I had them made by a local CNC shop. At first, I reached out to 2 large companies where you can just upload your 3D model to their site and get an online quote. Both of those options would have been manufactured in China, and the first quote was for $993, and the second was for $1,700. Next, I decided to reach out to some local options, and I only heard back from one of them. I was pretty surprised by their response. They offered to make these for $237 as long as I supplied the raw material. They were also by far the most responsive company I reached out to, and a coworker of mine had used them previously with only good things to say. I ordered 2 half-inch cast acrylic sheets for $125, so the total was $362 to get these 2 parts made. Unfortunately, it was pretty apparent I wasn't going to be able to make the hard tubing connections work. Even though the locations were spot on, the distro is tapped at a very slight angle, so my fittings weren't going to line up with my tubing. This isn't a big deal, I just need to order some barbed fittings and switch over to soft tubing. Honestly, I should have planned to do this from the beginning. It's going to make the install much easier. I did have a few holes that didn't get tapped for the motor mounting, but that's an easy fix. I really can't complain with the bargain price I received from that local shop. quick test fit and the pump mounting looks good. Alright, I can't take it anymore. Let's see how these parts look. Now I'm ready to start making my O-rings. This design uses 2mm cord stock, and I undersized my O-ring grooves very slightly so the cord doesn't want to pop out while I get it all set in place. I'm really glad I did this. If the O-ring didn't want to stay put, I can see how this process could easily become a nightmare. I'm just cutting the cord to length and using some super glue to join the ends. These are just some feet I decided to make for the computer. These are temporary, and it's just going to make it a lot easier to work on it while it's on the table. With the O-rings finished, I'm ready to marry the two panels. I'm going to install all of these screws by hand so I can be careful not to over tighten. The last thing I want to do at this stage is crack one of these panels. I'm going to check this plate for leaks before I attempt to connect it with the rest of my computer. I've got some more temporary feet to hold the distro vertically, and I've got soft tubing to join each of the ports. I'm starting to add the distilled water slowly, and once the reservoir is full, I'm going to power on the pumps for the first time. The reservoir ran dry pretty quickly, so then it was just a matter of refilling and repeating the process until I had worked enough water into the rest of the loop that it could start refilling the reservoir on its own. So close. And then I let it run the rest of the evening to make sure it was going to stay dry. It's the next morning, and I'm going to drain the system before I start making moves to connect up everything to the actual computer. I'm not going to fully seat the distro into the frame just yet. I want to get everything connected with extended tubing so I can try to boot the computer for the first time. If I run into issues, I still want full access to the entire build, so it'll be nice to have the distro out in front with some space to work. First, I ran another leak test with no power connected to the actual computer. I just wanted to make sure I didn't have any leaks on the computer side. Everything looks good, so I'm going to start by connecting my fan hubs. And with that, I had enough confidence to try and boot the rest of the system. While I have it running, I'm going to go ahead and install Windows from a boot drive. Today has been a big confidence boost, but I still have a lot left to finish. I'm going to install my LED strips, which will slip right into the aluminum framing. This will eventually edge light the entire distro plate, top and bottom. With those installed, we're ready to fully seat the distro into its final position, draining it for hopefully the last time. I mentioned I switched to soft tubing for most of my connections, but I had to stick with rigid tubing for the GPU. The saw fittings were too tall, and I didn't have enough clearance between the GPU and the distro to fit them here. The next evening, I was ready to fill the loop for the final time. I mixed in a corrosion inhibitor with my distilled water to give the system some long-term protection. Now to route the pump wires into the case through these clearance holes in the distro. Next, I have my case fans, and I have some brackets for these that the fan kind of snaps into, and then that gives me some mounting holes to come off of the frame. If you've stuck around this long, I'm sure you're a little curious to see how this computer actually performs. When I'm in the middle of rendering out a 4K animation and the GPU is near full utilization, my temperature still won't climb above 40 degrees Celsius. For the CPU, my core temperature hasn't gone above 50 degrees Celsius during any of my stress testing. Using AquaSuite, I'm able to control my fan speeds using the water temperature probes just like I planned. And with all of this radiator capacity, the fans barely have to spin to maintain a stable temperature for my loop. The performance has been so good that I've started experimenting with overclocking, and I'm going to continue to see how much extra juice I can squeeze out of this GPU. But probably the best way to show what an improvement this computer has been over my last one is by rendering the same image on both and comparing how long it takes. So let's take a look at a render I used earlier in this video. And on my original computer, this frame takes just over 2 minutes to fully render at 1080p. On my wall-mounted rig, this image is done in 5 seconds. Now let's render it again at 4K, And yeah, it's finishing a 4K version of that image in 15 seconds. I think that's a good way to wrap this one up. This new computer is gonna really speed up my workflow for this channel, and I'm really excited to put it to work. Thank you so much for watching. We'll see you in the next one.